Okay, last lecture, we stop at this equation. We have two equations. One is for force, one is for energy. So make sure you go and see example 5, example 6. Okay. Now we look at bonding. You have primary bond and secondary bond. So this morning, we only spend maybe 10 minutes. Then we summarize chapter 2, we go into chapter 3. Okay. This one you read. Okay. So ionic bond. Ionic bond, positive charge, negative charge join together, they become ionic charge. Number of positive charge cation, it can be packed around an anion. Positive charge can pack around an anion. We use, later you'll see packing efficiency. They are influenced by two factors. One is their size and their charges. Okay. So you'll be seeing in the middle later, this is anion. Anion is negative charge. You will see this is positive charge. Let's say it's surrounded by 4. Then we'll give one number to this kind of configuration. Okay. Sometimes you see 2, sometimes you see 1, sometimes you see minimum will be 3, maximum it depends. Okay. So for example, NaCl, it looks something like that. All right. So this one we'll learn about the packing efficiency in chapter 3 later. So if you compare CSCl and NaCl, so you see the orientation, how they pack. This is just your observation. Later in chapter 3, we'll look into detail. There's some calculation to calculate the number of positive charge cation around there. So the calculation that we see on the screen here, you take positive charge divided by negative charge, you get the number. This number is the ratio of the packing. Right. So first formula for this morning, we take positive charge radius divided by negative charge radius, you get the ratio. You take the radius. So if you compare two material, if the number is higher, means you can pack less, means more space there. More space there. If the ratio is low, you see it's very packed, less space there. Again, the detail will be in chapter 3. This one, okay. Rest you read. For example, LiFi. Okay, LiFi. Again, I won't ask you to draw this one. Just tell you what is ionic bond. Okay. Now, if we take this ionic bond, positive and negative combined together, in the experiment, these ions, when they combine, they form a compound. The heat release will be 600 something kilojoule per mole. Right. So this, when you can measure this heat, when these two items join together, then you will feel that it's heat, heat coming out. So we give we do some calculation and some measurement. We convert into a number about 600 something. So there are few steps how this heat can be generated. When the ionic bond, there are some steps. First, the lithium and the lithium and ferrum, they change to positive charge or negative charge. It depends, right? So for example, lithium on the left hand side, it tends to let go electron. So it becomes Li positive. Then F will receive one electron. It become F negative. So these are the first two steps lah. First step, you get anion, you get one energy. Then F become negative, you get one energy. Okay. Okay, these two steps is called atomization. Atomization. First two steps mean they change the state. They change the state. You have three states in metal. In metals, you have solid, liquid, and gas. So it depends on the energy. It can be solid become gases. You add energy. If a gas you want to become solid, you remove energy. Yeah. So the first two steps is change state from solid to become gas. Then the rest is just either receive electron or get away electron. So for example, lithium, they have one electron outside. So to let go, there's another energy happen over there, right? Same with number 4, then they form. Then they form. So when they form a solid, right? So from gas to solid, then the energy is called lattice energy. This one will be covered in chapter 3 extensively. Okay. So just have some understanding lah. Normally the component or the element will change from solid to liquid or gas. There's a process. Then after into gases, it change into positive charge, negative charge. After that, they will combine together, become new compound. It will reverse back, become stable solid. So there are some energy exchange there. Two technical word is the first one is atomization. Atomization, it is from state to another state. Another one is the last one, lattice energy, which is formation of gases into solid. It's called lattice energy. So we have one general equation introduced by Hayes law. Hayes law. Second equation for today. Hayes law, where you add all the energy together, formation energy together. So it depends lah. What are the process you have? So here you have 1 to 5 for lithium and chlorine. Okay. Okay. So how you get the energy? This one you get from material encyclopedia, delta HO, the total heat. They already measure in the experiment. So then this one also in the encyclopedia, from one state to another one, will give you one number. Then another one is missing. So you need to find the missing numbers. Okay, so these are the example lah. Example. So this is a combination. Just now you see lithium and ferrum. And this chart, you have lithium, chlorine, NaCl. So lattice energy, you have two columns. So when in the test or final exam, don't read the wrong column. The one on the left is kilojoule per mole. The one on the right is kilocalorie per mole. Usually we'll use joule because of the constant value we are using. Okay, if you see example 5 and 6, we convert energy into joule. This is the melting temperature. Okay, so again, you keep repeating seeing this periodic table. So previous class we look at radius. When we move from the top to bottom, what happened to the radius? Increase, increase means the sphere become bigger and bigger. If you move from the left to right, what happened to the size of the sphere? It will shrink a little bit because of the positive charge. Because of the positive charge. And just to recap, you should able to write the SPDF numbers on this periodic table. Don't confuse with the middle one and bottom one. There are some numbers coding in the middle one. Okay. Especially row number 4. It is not with number 4. The detailed one refer to the previous slides. Okay. Just need to highlight all this energy are negative value. So when you see this one, it will go, you will see all value are negative. So when you do substitution, remember don't use positive value. They are negative value. So ionic bonding, you take positive charge, negative charge, or the family 1, 2, 3 combined with 5, 6, 7, you will form ionic bonding. You see the melting temperature. Their melting temperature is a bit higher compared to covalent or other bonding. Okay. So these are the general properties of ionic bonding. They are hard, rigid, strong, and brittle. Okay. And ionic solid, after they form a stable compound, they do not conduct electric. They are excellent insulator. That's why if you use the old battery, lithium battery especially, why old battery, if you do not charge it properly, they cannot produce energy. The newly formed compound inside the battery become insulator. The detail of how they form insulator, that one you can watch on YouTube lah. Okay, this one. Okay, so this one, when they melt in water, they form ion and positive charge, negative charge. Then there is electricity happen lah. Like you mix NaCl into water, then you put in two probe, they will have a positive charge and negative charge. So this is a ionic bonding solid. So if you hit a ionic solid compound, you'll see B, C, D happen. So you have a first column, second column, third column, fourth column. So they are joined together with positive charge, negative charge. So when you hit with the external forces, this row, the first row, first and second column will move to shift down. Okay, they will shift down. They will shift down until you will see positive, positive, they will repel each other. So this is why they are brittle. They are easy to break. Okay, the rest you read. Next, we look at covalent bonding. Covalent bonding, the keyword here is non-metal. They join together among non-metal. So example will be hydrogen. Again, hydrogen is a very special compound or element. All right. So hydrogen, they are sharing electron. The rest you read. Okay. So this chart, you've seen this one before. There's a y-axis potential energy in the unit of EV. So you can convert 1 EV equal to how many joule in the previous class. If you missed that one, also go back to the previous class. So when two non-metal element, they are formed, or you pull them away together, the potential energy will drop. So the potential energy will be the potential energy means the differences of energy will be very big at when they are close, where the distance of AO. This one, if you're not familiar with this one, go back to example 5 and 6 of previous class. We discussed about how to calculate the force and energy. So same, if you pull them away, the potential energy will be decreased and become flat. So this is Lewis electron dot presentation. So you have single bond, double bond, triple bond, for example. So single bond means sharing one pair of electron. Then double bond means double pair. Triple bond means three pairs lah. Try to remember at least 3 examples. If the question asks you, give example of ionic bonding, covalent bonding, these two. Some of the information not inside my slides, you need to go and find out. Okay. The rest you read. Okay, covalent bonding depend on these 4 factors. Previously, we talked about ionic bonding. Ionic bonding also have some factor that influence it. Memorize that one. Covalent bonding, this slide also important. You try to memorize these 4. The question will ask you something. What are the factors that affect the bonding energy for covalent bonds? So these are expected answer lah. Very short answer. This one can be 2 marks up to 4 marks. It depends on the question. So if this come out in test, usually will be 4 marks. If it come out in final, usually will be 2 marks. Okay. As you read. Bond energy. So this is another chart. So by looking at the single bond, double bond, triple bond, and so on, if you look at carbon and carbon, you compare them side by side, you can know what happened if you have a single bond, double bond, triple bond. The bond energy will be more. It makes sense, right? So again, you have 2 columns. One is kilo Kelvin mole, one is kilojoule mole. Read carefully. Just now, the example I show you, kilojoule is on the left. This table or this chart, the kilojoule is on the right. It's not to trick you, but this is what we have. So when you read the value for your calculation, just be careful. Then the bond of the length was given. Okay, so as you can see, if you have single bond, double bond, triple bond, you move from single bond to triple bond, you see what happened to the bond length. It becomes shorter. It's like a rubber band. You have more rubber band, you will pull them closer. Okay. Then it depends on your combination, carbon with other combination. So this one, if you look at the periodic table, the position of HNO, you will see that the value also change. Apply for the rest. Okay. So this one also, if you this one your homework. You go and observe this table. See if you're able to see these two statements here. The higher the bond order, the bond length will be decreased. So you compare this first pair, this second pair, C and O. This one carbon carbon, carbon oxygen. Yeah. So you see the bond length is decreased. A bond length decrease, bond energy will increase. So if this one decrease, the energy will increase. So attraction force is strong in them lah, in covalent bond. So this one also you read lah. So it just tell you the molecular arrangement. If you take carbon combined with all these three member here, you take carbon combined with Cl, Br, and I, and you know the SPDF already. So this one got at row number 3, Br at row number 4, I at row number 5. Okay, so as you move down from the top to bottom, Cl, Br, Lr, the size sphere is increasing. Okay, but carbon is a bit small compared to them. Okay, this one you read lah. Okay. So the diameter, or this one we already mentioned just now. All right. As you study SPDF, we will move from the top to bottom. Diameter, diameter will be, the I will be higher. They flip from our statement. I will be higher, and then we move to chlorine. So you need to root back at the sequence. Sequence. It happened it happened on the group 1, 2, 3 over here. If you move from the hydrogen and then move down, the group number 1 to number 7, the radius is increasing. But a bit flip if you move to the right hand side. Right hand side, especially 5, 6, 7, because they have a inner positive charge inside. So if you move down, the stronger the positive charge over here. The inner core have a stronger charge. So if you move down from here, so it just makes sense lah. It just makes sense. Okay, non-polar, polar. Polar, non-polar means there's a direction. Okay, non-polar means there's no, there's a balance of positive negative charge. So the bonding will be equal. Example, hydrogen, barium. This is non-polar. Polar is there is imbalance in their charges. The differences is bonding electron equal or non-equal. If it's equal, become non-polar. Unequal, become polar. Okay. So as for example, something like that. Okay. F and H, you see the radius is a bigger compared to hydrogen. And if you form the same element, usually the size will be the same. So there is a same positive charge or negative charge, the electromagnetic. Okay. Okay. So as you know, you have a bigger radius, you have a higher EV or potential energy. All right. Yeah. Okay. So if you're given carbon, this one you should be able to. This one also you read how carbon share their electron. Okay. So this one is orbital diagram. Orbital diagram from ground state to the electron share with the p, share with p. So this is called hybridization of carbon to form single bond. So this is carbon 1, 2, 3, 4, 5, 6. If you look at this diagram, so we got 6 electron. So this is S, then this is S, P, this P. So you have 2P here, right? So you have this configuration. 1s2, 2s2, 2p2. We call it ground state. The one that you see on the periodic table is ground state. So during they form a single bond, they break the second highway S electron to the p orbital. They move the far right to the parking space here. Okay. So when you have 4 individual electron, meaning they are forming single single bond, single bond. Okay. So you read, is this one happen in the carbon element. Okay, this one just for your information. If you see these complex things, usually in the diamond or those expensive stone. Okay. Okay. Then another one is a hydrocarbon. Hydrocarbon, there is a specific chapter for this one. I think the last second chapter on a polymer. So this one is C and H. You have seen this one in your SPM or secondary school already. Okay, the rest we read. Okay, this is just an elaboration on how you convert this presentation into Bose model. This is called Bose model. When you see this one, it's Bose model. Look carefully if the question asks you to use Bose model or orbital box diagram, or ask you to write electron configuration as PDF. Don't give Levi's presentation if the question asks you to use bond presentation. Yeah, this one got some student, they make careless mistakes. The question already asks you to use Bose model, but some students still see using this one in the answer. Where is it? Okay. Okay, never mind. We move on. So these are the ring and so on. Okay. So you will see this symbol in the final exam for sure. This is a ring. This is also a ring. This ring represents this one. You don't need to memorize. You will see this one at the back of the question reference in the table. So today you just need to know that, oh, I've seen this one, I've seen this one. And then this shape equal to this one, this shape equal to this one. Because at the end of the final exam, you need to know how to calculate how many hydrogen carbon inside the compound. Okay. This one you read. This one you read. So covalent bonding, mostly they are gases, liquid, low melting, and they are molecular, means they cannot form as a single compound. Okay. This one you read. Okay. The next one we have done with the covalent bonding. Under primary bonding, you have 2 types. Primary, you have ionic, you have covalent. Then the next one is metallic bond. Metallic, from the word itself, you know, is formed from metal. Okay. So usually they are group 1 and 2. Hide the slide here. Okay, metals. Okay, the rest you read. Metals, they sharing ions together in the sea of that one. So the electron will go running around in the compound. Copper. Okay, copper. This is how you see. This one you see. This one in chapter 3 later. Okay. This one you read. This one also. Try to observe. Okay, by now you should be able to understand electron configuration of all this one. Okay. And bonding energy, again, you have two columns. One is kilojoule, one is in Kelvin. Usually we don't use Kelvin in this module. Then melting point. Okay. Now usually the question in the exam, you have three, let's say question 1, you have A, B, C. A usually is more on theory. To ask you factor, advantages, property that you can memorize. B usually will be a diagram or analysis. Okay, so this one there's some formula lah. There's expect to have equation over here lah. C, you need to answer how, why. This is your explanation. This one is more higher thinking order. This one low level, like primary school, secondary school. You are trained to memorize things. So this one we give chance to those you are still stay at secondary school learning style, but this one usually very low marks. Then you start go into universities, degree level, you start to have some analysis using equation for that respective subject. Okay, then at the end, most of the question in engineering or degree level, you need to explain why. You get a value, why. You get a negative, why. You get positive, why. Then make comparison sometimes, or how to improve the things. This one higher level. Okay, 25 marks. Normally this one is 5. This one is 10. This one is 10. Usually like that. Okay, so you try to change your learning styles. You're now at the university level. Try to always ask question why. Why this one happened? Why that one happened? Or how do I improve it? And so on. Okay, this one, if we move from the level 4, we move from the left to right. Okay, number of valence increase, attraction force positive, electron in the cloud also increase. So that's why you see all this happen to the bonding energy, melting energy, and electron configuration. Okay. So this is just explain why this one, these two, why copper is suddenly jump from the electron jumping around. Okay. So you see like nickel and copper, you see the bonding energy drop. The melting temperature also drop. This one D8C2, D8S4S2, and D10 4S1. You go to higher highway, you need more energy. You are in the higher order of highway, you need more energy to stay there. So for example, this one, Ni you see 4s2. So this one you need higher energy. Cu 4s1, you only have one, but D10 is a much lower energy. Although you have although you have a higher number of electron. Like for example, Ni you have 10 electron, 8 plus 2, 10. Then copper you have 11. However, the bonding energy is lower for copper because of the position of the electron. Okay. Metallic, you know lah, they are pure. For pure metal, they are more easier to form something. You heat them, you become flat and so on. So this is on the presentation. You give it external force, so the metal will deform. It will just shift around. It won't like the ionic bonding just now. Ionic bonding is shift then break. This one you won't break. You just shift around like a jelly. The rest you read. Pure metal, good conductor of electric, heat. Use this one for your experiment, for your experiment report. Explain. There's one experiment on heat conductivity. It is a rod, metal rod. There's a candle here. You give the heat to this one. Then you mount a pin. You mount a pin here with a candle sticking here. So when the heat transfer from one end to another end, this will drop, right? So there's some analysis. There's a distance. This is L. Then you give heat. Then you record the time. How long it takes from here to here, let's say 5 cm. How long the heat transfer from one point to another point in let's say 10 seconds. You need to do analysis on the heat transfer. Okay, and then explain what is this, why this one so fast, that one so fast. You're given 4 types of metals: copper, stainless steels, and so on. Okay, this one looks simple, but in your experiment, please use chapter 1, conductivity, bonding to explain. Okay. Mixed bonding, you have these 4 types: ionic covalent, metal covalent, metallic ionic, ionic covalent, metallic. So you have usual one, you only have ion covalent. This one at primary, secondary level, means secondary level education. When you come to universities, you start about material. There's one more, metallic. Okay, primary you have 3: ionic, covalent, and metallic. So when you see the word mixed bonding, means you mix around. You mix around between these 3 types of primary bonding. It can be ionic covalent, it can be metal covalent, it can be metallic ionic. Okay. Then it can be 3. Okay. The rest you read. Okay. There's one equation which is bonus mark lah. Remember, memorize this one. The third equation for today. Percentage of ionic character will give you this equation: 1 minus e exponential 1 minus 1 over 4 xa minus xb square multiplied by 100%. This is percentage of ionic character. The higher the numbers, it means is you have a more ionic behavior. Okay. Remember this one. This formula won't be given. We expect you to know and apply. So X, A, X, B, they are electronegativity. This one you refer to table. There's a table of electronegativity. So you've given one compound, second compound, then you read from the table, substitute here. Okay. Oh, this is called Pauling equation. Sometimes the question is so kind, it will just direct you or force you to use this equation. By applying Pauling equation, analyze something. Okay. Okay, the rest you read. I just give you some example application in the real case. Gallium arsenate and so on. GaA. This one, another one. Might not be familiar for engineering student, but you cannot run away because your time is all these nanotechnologies. So you will come across all these names after you graduate, work in the industry. You will see all these names. Okay, let's see how we apply Pauling equation. Then we conclude chapter 2. So calculate percentage of semiconducting compound GAS, GASA and ZNSE in Pauling. Okay. So using Pauling equation. So this will be seeing at the back of the appendix if this question come up. So you need to go and find what is GA inside here. So you write the equation of the Pauling equation, percentage of IC equal to bracket multiply 100%. So go and find GA. GA is 1.6. AS is 2.0. Okay. So you just apply to that. You just substitute inside here. Okay. GA is A. AS is B. But anyway, you minus, you bracket, you still get the same answer if you mix around. But you need to tell me which one is A, which one is B in your calculation. If you miss this one, then it depends. Sometimes I don't give you marks. Sometimes I'll just give you, I will circle this one. If you mix around, circle this one, wrong substitution value. Even though you're so lucky, you get the same answer. You won't get marks for the value. Okay. Okay, so you substitute, the answer is 4% for this one. Second one, ZE, you apply the same. All right. Can you calculate? Let's say I pull this one. What is the percentage of IC for ZNSE? Let's say I just ZNSE is SE, this one. ZN is here. Okay. Are you able to find the answer? What is the answer for ZNSE? You write SA equal. XA is what? What is the value for XA? What is XA value? 1.4. How do you get 1.4? Okay. I asked you about SA. XA, sorry, XA. Where is zinc? 1.6. Okay. Then XB, SE is what? 2.4. Can you try pressing calculator? Maybe some of you never pressed a calculator before. So what's the answer for the second ZNSE? What do you get? How many percent? Huh? 14. 14.8. Any others? Do you get the same number? Does it get the same number? Try to press. Don't wait until tomorrow exam already, then only you come and practice this one. Okay. The answer will be 1.4 something, 1.48 or something. Okay. Okay. Metal bonding, this one also you read. Metal covalent makes this one you read. Okay, secondary bonding will be something like this lah, dipole electron. This one I won't ask you lah. I won't ask. Of course, there are some equation by using the moment equation. You have forces multiplied by the perpendicular distance, you get the dipole moment. Okay, Van der Waals. Van der Waals also a very complex factor, but we won't ask you on the Van der Waals. This one you read lah, you read. Fluctuating. So just the question that might be come out is just ask you example that having Van der Waals bonding lah, or secondary bonding. So these are the name. 1, 2, 3, 4, 5, 6. Remember maybe 4 or 3. It depends on the question. Okay. So these are the noble gas normally, secondary bonding. They are noble gas. So from the periodic table, we expect you to know how to explain metallic bonding, ionic bonding, covalent bonding. Then what happened to the noble gas? What are the bonding they have? Answer is secondary bonding. So then melting and boiling temperature, they increase if you move from the top to bottom. We refer to this table. This is negative value, negative 2000 to negative 71. Actually, the temperature is increasing. Okay, because the size, the atomic size increase. Atomic size increase, and also the stronger bonding force there. This one you read lah. Another bondings called dipole. This one you read lah. Okay, this one for your information. Now, application of this bonding, you see glasses. In normal application, the glass will break if you cool down water. This one at I think some winter places. See the graph slowly. This is a real-time visual. Okay. This also explains why when you design something that work in the fall season, country with a fall season or extreme weather, you need to be careful. Especially you're involved in the R&D design department later. You'll see, like for example, this one. The pot is break because of the water expand during winter. So they put this component outside, then they leave it, then this one broken. So application of this one, also in the earlier days, the radiator in the car, when the engineer don't have the knowledge of this bonding, when they go into mass production, most of the car radiator broke down during winter time. Then they need to recall all the car back. So these are the things lah. Solid ice, this one is one chapter itself, so we don't go deep into this one. Water is a very special component. So these are the things that in the radiator, so it break lah. So that's why in the Europe country or those winter weather, they will recommend you to use defreeze liquid inside the cooling system. So sometimes, for example, BMW or Mercedes-Benz that import from Europe, when they come to Asia, one problem happened. The rubber will become brittle very easily because of the weather that we have. And also Malaysian car export to Europe, if no modification done, most of the time the car need to recall back because of the material use. Okay. This is a reason also why, for example, aircraft, when they launch a new aircraft, they require the aircraft to fly around the globe and landed at different airport with a different temperature. So the two extreme place will be desert landing and also in the Antarctica, the two north and south pole, they need to land over there. So that they need to see what happen if you aircraft in the extreme weather. The tires, the brake liquid, and all these things. Right? And you'll see all these pothole in the Europe country especially. The pothole is not because of the car like Malaysia. Malaysia, we have pothole because of the heavy vehicle. But in Europe, you see this one is because of the icing. It's so cold, and then the water molecule expand the road lah. Okay, the rest you read. Okay, so this is a good table for you to remember example. In your example, try not to use hydrogen. Please remove hydrogen in your exam answer. Remember maybe 3 or 4 in ionic, 3 or 4 in covalent, 3 or 4 in metallics, 3 or 4 in van der Waals. This table only give you some limited. You need to go and find another missing element. Yeah. This is some question for you. You'll see something like this in your test. But of course, in exam, it will be more higher question. You see something like this, ask you to give you the electron configuration. Then go and guess what is this element. Okay, so go and practice all these questions. You can. All right. Then find the energy and so on. So these are the example of question that might come out lah. or expected. Okay, we have maybe 5 minutes breaks. We continue 9:05. We go into chapter 3.